All right, hey everybody, I'm back here with method number 2. So I want to call this one the segment addition method. Now, in this one here, I have my knowns already marked up here. I know that KR is 12, RT is 4, and 20 is KU. So hopefully you watched the other video where we got that set up. I'm going to use kind of the recommended method down here actually to solve this one. So perhaps you looked at this, that in the textbook, they give you a little tip for number 25. Now the problem is I don't think I assigned number 25. Did I? I don't know. I thought I just assigned the EBITs. Maybe I did assign number 25 here. So they're giving you a little tip about how to solve this. So many of you might be able to figure this out based on this little tip here. But in this problem here, we're actually going to be able to solve this by just setting up one proportion, right? One proportion here. Actually, the given proportion we're able to do it here. So you might be asking, how am I going to be able to use this given proportion to actually solve this problem? Because I know what KR is, right? KR is 12. I know what RT is. RT is 4. But I don't know what KS and I don't know what SU are, right? I don't know what those are here. So let me put in my knowns. I know that this is 12 and then that's 4. My unknowns here, KS and SU. And it turns out what they're recommending down here is actually just defining, right? Defining freaking variables here. So this is number 25, so you didn't know what KR was, you didn't know what RT was here. But if we define variables for a variable actually for one of these segments here, we can actually come up with an expression for the other segment because we know that this plus that equals to 20, right? That's given to us here as 20 here. So try to follow what I'm doing here for a second, okay? So the way that I'm gonna solve this problem here, similar to the last way I solved it here, I'm gonna let length SU be equal to X, okay? So I'm gonna make this X here. I'm gonna change this to X right there, okay? So I'm gonna go ahead and put that into the denominator of this proportion. Okay, so it turns out, right, if this distance here from here to here is length of X length, right? It's an unknown length, right? So I'm assigning it a variable so that I can solve for it and determine what exactly that length is later. So if that is distance X, and maybe I'll move it over here so it's a little bit more clear. There. Okay, if that's distance X, we can actually define an expression for this distance, right? This distance. And how would I do that? Well, if we think about this here, again, yeah, this all comes back to the segment addition postulate here. If I have KS and I added SU to it, okay, I'm not gonna write SU right here, I'm gonna write X because we let segment SU be a length of X, right? We're just assigning it a variable so we can solve for it later. We know that KS plus plus SU is equal to KU, right, for this segment addition postulate. So this adds to 20 here, okay? This adds to 20 here. So what it turns out here is that if I take away X from both sides, right, let me take away X from both sides, boom, boom, KS can be represented as an expression in this problem as 20 minus whatever this distance SU is, right? 20 minus this SU is. So here, I'm going to assign this expression to it. So 20 minus X, let's just let that represent that length here, KS. And then this is X right here. We'd have to add that to the 20 to get up to the 20 here. And this is how we're going to do this. Because now if I move this, instead of writing KS right here, I write 20 minus X. And I'm going to put that in the numerator over here. This is something that we can solve. And why can we solve this? Well, now we no longer have KS and SU, right? So we don't only have two variables here that are unknown. We just have one variable, which is X, okay? We have the length X, which represents SU, and then we have the length X up top here because 20 minus that length of SU, that's going to represent, right? Again, this represents KS right here, right? That equals KS here because we moved around the segment addition postulate, okay? So this is something that is going to come up actually. It's going to come up quite a bit in the next few chapters is we'll have a length of a whole part and how do we write expressions that can help us describe what the other parts are, like might relate to one another. Well, if this certain length here, this is dependent, right? The length of KS is dependent on the length of SU because they got to add up to 20 with one another. So whatever the length of this is here, take it away from 20, and that's going to tell you what length of KS is here. And this problem here we can solve. We can apply the means extremes property, right? The cross multiplication here. I do cross multiplication like this. I circle that, right? Multiply my means together, and I'm going to get 4 times by 20 minus X, and that's going to be equal to, let's do ahead and cross multiply action here. I'm going to grab those guys here, and I got 12 times by X, which is 12X, and this is something that we can solve here. Hey, I can divide both sides by 4. I might do that because I noticed that this is 4 times the quantity, 20 minus X, so if we just divide it by 4, right, we no longer need to distribute that multiplying by 4 here. So now I have 20 minus X, and that's equal to 12x over 4, which is going to be 3. What did I do wrong here? I did something wrong here, didn't I? Let's see. Ooh, I must have done something wrong. What did I do wrong? Let's see. Oh, 4, let's see, divided by 4 and 12x. SU. Mr. Fortin's his mind is playing tricks on him because he thinks he's getting 17 for x, and that doesn't make sense because we solved the problem differently last time. What was the mistake that I made? I'm going to pause this for a second to look at this. All right, 2 seconds have gone by. I was being silly. This is not 12 divided by 4. It's 12x divided by 4. So this would simplify to 3, and then we still have the x there, so it's 3x here. Okay, so I'm going to add x to both sides, right? So I can do addition property of equality to get my numbers on one side and my x expressions on the other. You should know that from Algebra 1. Divide both sides by 4. And here, x is equal to 5. And if we remember, x represents the length of x of SU. So here we've solved for what SU is. And SU has to be 5. 20 minus x, what's 20 minus 5? Well, that's 15. And it checks out, right? Because 15 plus 5 is equal to 20. So segment addition postulate got us there. Last step is KT, again, just 12 plus 4, and that equals 16. So we even see here, like, look at all these numbers here. This 12 to 16 is in a 3 to 4 ratio. Wait, no, that's not right. What am I talking about here? Wait, KR to KS. Oh, this is 15 as I'm looking at here. Yeah, sorry, it's in a 4 to 5 ratio. 4 to 5 ratio, and 16 to 20 is actually in a 4 to 5 ratio. They're both divisible by 4. You'd get 4 here and 5 there if you go to divide both by 4. So we got our answers again. That's way number 2 of doing it. I'm going to show you a third way, which relates to what we did on Friday in our group work in class.